Thanks again. Our next item is the effect of climate change on Hurricane Ian. And this is a presentation from Michael Wehner of the Lawrence Berkeley National Laboratory. And I think it's another example of how all of this stuff really does tie together. And Michael is joining us remotely. The purpose is to discuss the findings and implications of the findings in a rapid analysis study conducted on the rainfall of Hurricane Ian during the time of impact on Florida, and a discussion of the likelihood that other impacts of Hurricane Ian were also worsened by global warming. And the connection to the CCMP is that it relates to fish, wildlife, and habitat restoration action. 3.1, assist in assessing and promoting the economic, social, and environmental benefits of land protection and habitat restoration, including as a response to climate stressors. Michael.
Hi, this is Michael. Can you hear me?
Yes.
Okay, great. So I'm going to brief you on a statement we made for Hurricane Ian and some of the what we know about how climate change affects hurricanes in general. Are the slides going to advance rapidly like this? Or are you doing it manually?
We're doing it manually.
Okay, all right. So I'll just tell you next slide. This is a disclaimer just to say that I'm speaking on my own behalf and not that of the United States Department of Energy, the University of California, or the Lawrence Berkeley National Laboratory. So next slide, please. So here is Hurricane Ian just before, well, as it was making its impact on the Gulf Coast of Florida and inland. The next slide, please. There were two major kinds of damages in Florida, at least from Hurricane Ian. The storm surge in Fort Myers. You can see the picture on the left. Was resulted from about 15 feet of storm surge, which is a lot. Buildings don't tend to withstand that very well unless they've been reinforced. And then the second kind of damage is from the rain. So that's a wind-based damage, and I call that saltwater flooding. But inland, it tends to be freshwater flooding from the rain. This is a picture, a satellite photo that shows some of the discharge into the Gulf of the muddy water that flowed, past people's houses first, and then onto the bay. Next slide, please. So let me brief you a little bit about what we know in general about climate change and hurricanes. How does it affect the wind? Well, theory and modeling tell us that go back, please. That the winds in the strongest storms become stronger. And this is because there's more available energy from a warmer ocean. And there's also more available energy from a moister atmosphere. That's something I'll talk about in a little bit. So the wind damages would be greater and storm surge would be larger because of this increased wind. But at the current time, we don't have a what I call a formal detection and attribution of this expected human-induced change, and that's because typically the way we look at this is through the instantaneous winds that set the Saffir-Simpson scale, and that is not a particularly good detection variable, and it becomes a signal and noise issue, and so there is a lot of debate on this, though. Whether or not that signal has yet emerged, I think there's very little debate that as the climate continues to warm, that the winds will become detectably stronger. Can you the next slide, please? So how does climate change affect the rain? And this is something we know a lot more about. Again, we go back to theory. We know that from a 19th century relationship that was developed to help make steam engines more efficient, called the Clausius-Clapeyron relationship, that the moisture in a fully saturated atmosphere increases at about 7% per degree centigrade of increase in the local air temperature. So when relative humidity is 100%, if it's a degree warmer, there's 7% more moisture in it. And We have shown, however, with modeling that hurricane rain actually increases at a rate greater than this. And we've done this on many, many storms now. Now, prior to Hurricane Harvey, I would have said that rain increased at 7%. But Hurricane Harvey was the first study where the community really dove into it. Recall this devastated the Houston area with a flood. In the meantime, we've looked at a lot of other storms. Hurricane Florence was the first one we did a rapid, actually a forecasted attribution statement about how much the climate change was affecting the rain. We looked at Hurricane Dorian, Maria, and Irma, 15 other storms in this paper by Chris Patricola and myself in Nature. I'm showing here a result for Hurricane Maria of a composite of many simulations showing the current precipitation that actually happened, and then what our estimate of how much climate change affected that pattern of and magnitude of precipitation in the middle panel, and then what would happen in a future very much warmer world at the end of the century without abatement of our carbon emissions. And you can see that there's the structural change in this pattern, and basically what we infer from this is that the winds are stronger, and so the dynamics of the storm is a little bit different, but the precipitation is actually affected by a great amount. Next slide, please. So earlier last year, prior to Hurricane Ian, Kevin Reed and I had published a paper on the effect of climate change on precipitation during the entire 2020 season. And this is going to be important because we use that methodology for Hurricane Ian. And it was built on our experience with previous storms. We had a lot of code, computer code left over from other storms that we sort of amalgamated together to do the entire season. And the mechanism here is we do two sets of hindcasts. They're hindcasts like a forecast, except the events already happened, so it's a little better informed. And we compared simulations of the storms that were the actual storms to a counterfactual storm without climate change. We call that a storyline. The storyline is that a cooler world that might have been without the human interference in the climate system. And we concluded in that paper that over the entire season, that extreme hurricane short-term rainfall increased by about 11%, and the extreme 3-day accumulated, the total, basically the total rainfall in the strong storms increased by about 8%. Next slide, please. So what do we say about Hurricane Ian? Oddly enough, we've found that Twitter is a very efficient way of communicating this kind of information. And on September 29th, while the storm was still over Central Florida, we tweeted that, I'll read this. Using the same attribution technique recently peer-reviewed in Nature Communications, this is for the 2020 season, preliminary analysis by Professor Kevin Reed and Michael Wehner shows more of the same for Ian. Human-induced climate change increased Ian's extreme rain rates by over 10%. And the over is actually an important caveat there. Next slide, please. So how do we come to this statement so quickly? I mean, this usually for Hurricane Harvey, we thought we did a pretty good job in that it took us only about 3 months to come up with an answer, but here we came up with an answer before the storm even had dissipated. And what we did is while the storm was sort of raging over the coast of Florida, Kevin said, let's try to do an attribution statement. And so he just fired up the old code and he reinitialized it with hurricane forecast data from National Weather Service. We went to bed and we had results early in the morning. And you can see here's a typical result from a composite of these simulations where the actual rain and the track is actually shown on the right in panel B, and then the counterfactual simulated storm on the left, rather, panel A shows eventually the same track, which is important in this kind of thing. But the colors are not quite as deeply blue, indicating that there's a lot less rain. Next slide, please. So our initial statement that we tweeted was deliberately conservative. We said over 10%. That was because we were trying to do this rapidly so that information could get out to people while the storm was still happening. And we have a revised statement in a paper under review. I'll make a comment about that in a minute. That specifically that the 99th percentile 3-day accumulated precipitation, so the rain in the rainiest parts of the storm, increased by about 18%. We put a confidence interval on that. This is our measure of uncertainty that range, the human increased amount of precipitation range from 15% to about 21%. And this is definitively super Clausius-Clapeyron, that 19th century relationship I mentioned of 7% per degree centigrade, because there's about just about 0.8 degrees centigrade a warming in the Gulf of Mexico off the coast of Florida in September's attributable to human influence. And that translates to about 3 times this Clausius-Clapeyron relationship. Next slide. So there's some opportunity for future work. I think, the amount of rain increase is sort of interesting, but I think what really matters on the ground is how does the flood increase? Now, we've done this for 2 storms. We've published extensively on Hurricane Harvey. This map is from Hurricane Harvey. And we're also currently looking at Hurricane Ida remnants in New Jersey, New York, and Pennsylvania, because a lot of people died there. The flood was rather interesting. And so for Hurricane Harvey, we basically came up with what I call an end-to-end impact attribution statement. So there's a 1 degree in the Gulf, and at the time of in that part of the Gulf for Hurricane Harvey, 1 degree of warming attributable to human activities, the burning of fossil fuels. That led to 20% more rain. That led to a 14% increase in the flood area, which is indicated by the difference between these 2 things in these 2 colored panels. And that led to 32% increase in the number of homes that were flooded. We have a similar statement for Hurricane, that shouldn't say Ian, that's supposed to say Ida, that 500,000 more people were flooded because of climate change. That's a more difficult flood to simulate, and that paper is I expect to be submitted in about a month or so. And both of these analyses reveal profound socioeconomic disparities in the impact. In other words, there are differences in income. Generally, the poor were impacted more than the rich, certainly more than the middle class, but also racial disparities as well. In the case of Hurricane Harvey, low-income Hispanic households were more impacted by climate change than the general population, revealing an environmental injustice. And we're searching for interested partners for Hurricane Ian. Basically, I need someone to help me with doing the flood. Next slide, please. So this 3 times the Clausius-Clapeyron scaling of hurricane rainfall implies more than just the rainfall increase. It means that the storm is more efficient at precipitating the available water, which only increased by 7%. We know that. Actually 7% times 0.08. And what the only explanation for this is, and that structural change in the Hurricane Maria slide sort of indicates this as well, that the winds are indeed stronger. And if the winds are indeed stronger in sort of some large scale integrated sense, that means that the storm surge is probably affected as well. And so with Mithun Deb and others at the Pacific Northwest National Laboratory in Washington State, we're exploring the possibility of using his storm surge model to via this storyline kind of world that might have been storyline to quantify the climate change impact on the surge for Ian. Here's a preliminary calculation of the surge that was. And so that's still hopefully something we'll do in the next couple of months. And that's my last slide. I'm happy to take questions.
Well, thank you very much for that great, bright outlook, Michael. Makes you wish.
Yeah, I'm sorry. It's never a happy story.
Yeah, no, that's you know, pretty strong analysis. You know, doesn't give us a lot to look forward to as far as, you know, mild spring rains, but any comments?
No, I think it is important to understand that there's a lot of climate change that's still baked into the system, regardless of what we do for reducing our emissions. Now, this new law, the Inflation Reduction Act, goes a long ways to reducing US emissions. It doesn't go far enough, of course, to halt climate change. Hopefully that will be the beginning of a process, both nationally and internationally, to get down to zero emissions so we can stabilize our climate at some level that's quite a bit warmer than now, but not, 4 degrees or something, which is what our business as usual path would be.
Right. Well, we really do appreciate kind of the preview of what your next releases are going to be.
I'll just jump in first and say, number one, this is extremely interesting and important work that you're doing, and definitely explain some of the things that we directly measured here. One of the things Nicole and myself were looking immediately after the storm at the rainfall data, and we saw this like supercell of rain that came down right over Northport. So in addition of receiving watershed contributions, it was just this, red dot that just of extreme rainfall that showed up based on rainfall measurements. And these are important aspects to think about, because we deal so much with stormwater pollution and flooding and issues down here because we're very low lying and have a high water table. So understanding that the future is going to have more and more of these extreme rainfall events really should inform our stormwater planning and building in extra capacity beyond what we need for normal stormwater and storm events to handle some of these extreme events as best we can. And I know that also the other thing, which you didn't touch upon, but which our research has been uncovering is, based on the warming, and it's tied to exactly what you're talking about, is the increased evapotranspiration. So what's happening on the land is also that the heat is wicking up moisture in ways that causes wetlands to dry out quicker and to shorten the hydro periods of those wetlands, and drop water tables, groundwater tables in other parts of the year based on higher temperatures. So you get this extreme of drier dries and wetter wets. So just to explain the flip side of this is that we're looking at, for hydrological restoration planning, you're going to need a lot more storage than you need even to restore to today's conditions. You're going to have to build more tanks to pulse out water during the dry season to try to prevent wildfires and issues like that, because we're going to see the increased evapotranspiration, especially inland. We looked at it and it has a profound impact in counties like Glades and Hendry counties, what the climate models show. So you have, these two extremes. Like right now, we already deal with flashy hydrology because we drained our systems. We've lost some of that natural attenuation of water flow, but it's going to become exacerbated. And we did this modeling recently for the Lower Shell Harbor Flatwoods Initiative and for the South Lake County Watershed Initiative. And basically we could see that over time, that even if we build in restoration to get closer to restoring to natural conditions based on current conditions, that climate change will be working against us. And over time, we will actually see those benefits be diminished unless we even do something above and beyond what is needed to restore based on, existing conditions and climate. So I just wanted to put that out there to give you kind of what we're seeing on the ground and to talk about how that feeds into your research in case that was helpful to you and to the other participants in the meeting.
I have a follow-up question. Have you analyzed any of the California storms and places too? Because it seems like those, more severe droughts and more severe flooding is happening in a lot of places.
Yeah, I actually have comments about both of these. For the Intergovernmental Panel on Climate Change report, actually the 5th assessment report, not the last one, the one before that, I looked at soil moisture in a warmer climate, and I concluded the following: that there was no place on the whole planet where soil moisture increased in a warmer world. And this is even in places where rainfall does increase, because rainfall doesn't change uniformly. That evapotranspiration, because of increased temperatures, outpaces that. And so in places where precipitation doesn't change much or where it reduces, this is really exacerbated. But even in places where the rainfall increases, the average soil moisture does not. In fact, it probably goes down. Regarding California, actually, I made a statement about that too. Actually, the day before the first big storm hit us here in the Bay Area, San Francisco Bay Area, that atmospheric river extreme precipitation would increase by about 5%. And again, this is a fairly conservative statement. Don't want to be too alarmist. The warming is a little less off the coast of California, and the storms are different. But Chris Patricola again and I and a group of consultants to the San Francisco Public Utilities Commission have been looking at extreme rainfall in these atmospheric river storms. We found that ones that have a extratropical cyclone associated with it are quite sensitive to warming. We have a recent paper out in Weather and Climate Extremes where we asked the Public Utilities Commission to choose 5 impactful storms, and those are the ones we looked at. Now that result is being used by the San Francisco Public Utilities Commission to revise their IDF curves. These are called intensity, duration, frequency curves, which are their design tool for the wastewater management sewer system. And to quote Susan Liao, who is one of their consultants and the former director, there ain't no pipe big enough. And so the city of San Francisco is trying to use this information to manage this urban storm runoff. And I think this kind of information is critical to being able to plan for the inevitable. And so, yes, we have looked at these storms, and not nearly as much as with hurricanes, actually, but as a community. But I think the answers are becoming quite clear.
Thank you very, very much for joining us and sharing that. Maura, did you have a question or comment?
Did you consider climate change effects on the speed of storms? Because it seems like some of our hurricanes are slowing down, or even like with Harvey going backwards in track, like Ian was extremely slow, which contributes to the precipitation and the storm surge, things like that. Yes,
there is a paper by a colleague of mine that we've written together. I'm not on that paper, but his papers, Jim Costing, found that hurricane over the United States, after they make landfall and then become what we call hurricane remnants, those are slowing down. And there is some evidence, not strong evidence, but some evidence that is attributable to climate change. And I tend to, sort of weakly agree with that. As far as Hurricane Harvey and the stall, that I think that's a different phenomena completely, and it's such a rare event that I don't think we can make any statements about climate change effect on Hurricane Harvey's stall. When I looked into observational record, we could only find one storm, maybe 2, where such a stall has actually happened, and that's just simply not enough data to draw much of a conclusion from.
We have-
But you know, if there is a stall, if there is a slowdown, that does mean that this would also contribute to increases in precipitation in any given location because the storm sits there longer.
Great. And we have a question from Elizabeth Long, City of Northport.
I just have a comment. It almost seems like the 100-year storms are more frequent than the 1% chance of happening. So I just throw it out there, maybe the regulatory agents, as we design stormwater systems to handle. Well, right now we're still on 25-year storm. Maybe we should be moving towards a 100-year, or call a 100-year storm a 25-year storm. But that
Well,
kind-
this can be quantified, and in fact, we do. We cannot use past historical records for even the present day to say to quantify, to say, you know, what a 100-year storm was based on past data is not accurate for what it is today. It's certainly not accurate for what will happen, you know, in the future with a warmer world. And so, you know, these kind of stationary data series is simply incorrect. And so I think that there's a reckoning to be had here that much of our planning for damages is based on outdated data, in my opinion.
Well, I don't want the reckoning with any insurance companies to, I could talk for days about that. One last question, any? Then we'll move along.